tonight. Okay, I think I might switch that back a bit. Yeah, I think it's better this way. So I'll just let you to do this thing. Share. Awesome, awesome, Mr. Jolas. Okay, it's great to have you join us tonight. We are at Unit 2 of Module 1. We're treating Unit 2 of Module 1 tonight. Okay, let me just use this opportunity to say hello and welcome everyone to this live channel, to this live stream. This is a series we've been taking, and it's on the course GST 105. That's History and Philosophy of Science. It's a course introduced to management students in their first year, their 100 level, and it's just to introduce them to what science is all about, the basics of science. And we started the class on this course. That was the day before yesterday, and we treated different definitions of science. We treated science, why science is different from non-science. We talked about different definitions of science from different authors, from different scholars, and we talked about science as a body of knowledge. We talked about science as a body of knowledge. We also talked about what comes into your mind, what comes across your mind when science is being mentioned as a body of knowledge. And we were able to say that science, okay, Mr. Julas, I think I've answered that question, but I think you didn't get it. So let me just say it again. We are taking Unit 2 of Module 1 just immediately after the last unit we took in our previous class. I'm aware we didn't, unfortunately, we were able to wrap up the class that night, but where we were is just one step before conclusion and summary for that class. So today we are starting with the next unit, which is the Unit 2 of Module 1. Mr. Julius, are you there already? So today we are taking Unit 2 of Module 1, and the topic is scientific method. What is scientific method? How it applies to reality, and how it applies to critical and creative thinking. So this we'll be talking about tonight. So in the introduction we have, in the last unit we talked about science as a body of knowledge, and we agreed that when we say science as a body of knowledge, we are referring to science as physics, science as chemistry, science as mathematics, science as biology. Now, we have also science as a method of acquiring knowledge, and we have science as an institution. All these will be lightly touched in our previous class. So today we'll be dwelling majorly on science as a means, as a method of acquiring knowledge, scientific knowledge, which is called scientific method. We will be discussed tonight in details now. So the objective of tonight's class is we will list sequentially the step of scientific method. We will as well, I want to say sequentially, one step at a time, following step by step. So we'll be explaining in details one example how the method can be used to solve life problem. We'll be talking about how method can be used to solve hypothetical scientific problem. Hypothetical in the sense that hypothesis, the testing of our assumptions. Access clearly the use of these steps of creating and critical thinking when giving a hypothetical case story. So all that we'll be discussing tonight. So on page 26 of the course material, the soft copy on page 26, we have 3.0, which is the main content. 3.1, scientific method of acquiring knowledge. Scientific method of acquiring knowledge. So, superficially, science is a collection of facts. Talking about superficially simply denotes something on the surface, something not on the in-depth. Mr. Joseph, it's good to have you join us tonight. Something on the surface, something that is outward, it has more of outward appearance, can be easily identified. So now, talking about science on a layman's level, it's a more of a collection of data, collection of facts. This fact is referred to as a body of knowledge. Now, this fact describe and explain the workings of nature. The gathering of fact that talks about what nature is all about. That is what science is superficially. But we all can agree that science is more than that. Science is not just superficial. Science is also, it has in-depth to things. So we have, although these facts are interesting, even fascinating, they are not the essence of science. Rather, the excitement of science lies in the intriguing observation and carefully designed experiments that scientists have devised to help us learn about nature. That is the beauty of science. Not just observing, not just getting to know these facts, but the processes involved in accumulating, the processes involved in gathering these facts is what matters. It doesn't really matter how you get to your final answer. What matters, although in mathematics, that's what the marking scheme is. I'm doing an illustration using mathematics now. If you are given a mathematical problem to solve, then you have to solve it step by step, and you'll be graded. The grading will be based on steps, not just your final answer. So now, the beauty of science is how that fact that explains what nature is all about is being gathered. Now, as intriguing as science, intriguing in the sense that something that keeps you on the edge, something that makes you want to know more, keeps you on the edge. As intriguing as science may be, its beauty lies in observing and careful design of experiments that scientists have developed. Now, the important thing here is the process of science, not just knowing the facts, but appreciating how scientists discover and continue to discover those facts. Now, the process is characterized by a sequence of steps, just like what I've been saying before now. You can remember very well in our introduction to psychology. I keep saying anything that has to do with a procedure, that has to do with step-by-step process of getting something that we can refer to as scientific. Now, it's been re-emphasized, it's been re-established here that the process is characterized by a sequence of steps which enable scientists to approach objective truth as closely as possible. Who said this? Morone and Moore and McCann in 1974. Now, taken slightly, most of the steps are common placed procedures carried out by people on a daily basis. Now, taken all together, they amount to one of the powerful tools man devised to know and to control nature. That is science. One of the powerful tools man has devised to know and control nature. Speaking about the nature of science, we'll get to know more of this as we proceed in the class. So now, these steps we are talking about, the step that makes it the beauty, the step that speaks about the beauty of science. What we are talking about now, we have the first step. we have observation. Observation is the first step. Now, what is observation and why is it the first step? What makes it so special? Why don't we have some other things on the list? Now, observation has to do with noticing. One thing you can always tie to observation is noticing, being sensitive. Now, according to what we have here, now knowledge comes from noticing resemblances and recurrences in events that happen around us. This is according to what Wilfred Trotter said. Wilfred said observation has to do with noticing resemblances and recurrences in events that happened around us. Now, observation is the first step of scientific method. Anything that cannot be observed cannot be investigated by science. The bedrock of science is observing, observation. As it is said here, he said, anything that cannot be observed cannot be investigated by science. For example, a young student observed that maize grains, maize, call them corn here, maize grains, which were placed in a wet container inside a dark cupboard, germinated, but that the leaves were pale yellow instead of the normal green color of leaves. This is an illustration of a student who placed a maize seed, the grain of the maize, in a wet container inside a dark cupboard. It's germinated, fine, but he noticed that the leaves were pale yellow. I think some of us who have been to the farm before should understand what this pale yellow looks like, instead of the normal green color leaves. Now, scientific observation, these are what he had noticed is a typical example of what it is to notice, to observe. You observe a specimen. Now, we have scientific observation can be both direct and indirect. Direct observation are made with the aid of the senses, just as our hypothetical students observe the maize grain with his eyes. Direct observation has to do with you using your senses, and one of the senses as human we have is one of the senses that we human we have is the sense of sight. We have the sense of smell, sight, and sound, and we have them. But now, according to what we have here, we have the direct observation, which has to do with observation that is being aided with human senses. So that is that for the direct observation, just as the students, hypothetical students, has observed the maize grain with his eyes. Now, indirect observations are performed with the aid of instruments. Now, indirect observations are performed with the aid of instruments. Atomic nuclear and magnetism, for example, cannot be perceived directly through our sense organs, but their effects can be observed with instruments. Now, what other things do you think can be observed indirectly? Now, we have, just like we have the atomic nuclear and magnetisms. These can't, things that we can't see with our bare eyes can't be perceived with our eyes. We have to use instruments like microscope, just like you are running a test or a kind of experiment on microorganisms. Definitely you might not be able to see them with your bare eyes. You have to run them on microscope to see them and observe them. So we have observations can also be classified into spontaneous or passive observation, which are unexpected, induced or active observations, which are deliberately looking out for facts. So we have that as that. So we have the effective spontaneous observation involves, first and foremost, noticing some object or events. The thing noticed will only have meaning if the mind of the observer either consciously or unconsciously relate it to some relevant knowledge of past experience. It can only be important if the observer, in the process of thinking over it, arrives at some hypothesis. Let's not forget what a hypothesis is. Hypothesis is our our guess. It's a structured guessing. So it has to go through some processes before it becomes a theory, before it becomes accepted. Now, from our hypothetical example, the student noticed that the pale yellow color of the leaves of the maize grain was different from the normal green color of the maize grain. Now, it thus relate what he observed with his previous knowledge. If he had no idea of what the leaf of a maize grain should look like, his observation would have been useless. But because he had known that for any I think we are back. Sorry for that. I think that was a network thing. So because he had known that for any normal speaking of which, the maize grain should be green, not pale yellow. So now the effective spontaneous observation has to do with noticing some object, and not just noticing this object, is now relating it to what you have known before. And now we are now using this to explain what, in the case of this hypothetical student, observing that the leaf of this maize grain is supposed to be green and not pale yellow. So then observation can be said to be effective. Now, powers of observation can be developed by cultivating the habit of watching things with an active, inquiring mind. The power of observation can be developed by cultivating what? The habit of watching things with an active, underline the word active, inquiring mind. Now, it is no exaggeration. It is no exaggeration, meaning we're adding 1 to 2 or 2 plus 2. It's what it is. To say that well-developed habits of observation are more important in scientific research or even in our daily living than a large accumulation of academic learning. Very well. An inquiring mind is way better than a large accumulation of academic learning. You can just learn and have it there. But an inquiring mind is always going back to what he has learned and apply them and make references to them. Now, correct. Mr. Jolas said you lost it. You lost what exactly? Okay, we are in page 27, the soft copy, and I'm basically talking about the spontaneous or the passive observation. We're talking about the direct and the indirect, And we also said observation can be classified into spontaneous and induced. So now I'm just talking about the spontaneous, and we are trying to make reference to what we talk about spontaneous. What you have observed, you have to relate it or make reference to what you have known. Are we on the same page now, Mr. Julius? I think the network is doing its thing again. So we have where exactly? Okay, observation can be classified into two. That's where we are into spontaneous and passive observation, induced or active observation. That's where we are. That's on page 27 on the soft copy. Please, if you are there, let me know, please. Excuse me. So we have that's that. So let's just move on. Now, as I said before, now powers of observation can be developed by cultivating. To be good, to be perfect, to be better at observing things, you have to cultivate the habit of watching things with an inquiring mind. Don't just see things on the superficial level. No, no, not experimentation. No, not experimentation, Mr. Jonas. Um, Now, look at this. Let's take it from the top. We said steps of science include the following. The steps of science. We are now on observation, which is the first step of science. Observation, very first step of science. That's where we are. Under observation now we said it can be divided into two, direct and indirect observation. We've spoken about that. Now we're not talking about classification of observation, and we said spontaneous and passive. Okay, also I'm saying you have it, so we can just move on. So under spontaneous and passive, or passive now, is what we are now talking about. You understand? Now we're now talking about correct observation is most okay. We said something about the power of observation, that it has to do with observing things with an active and inquiring mind. Now, so then we move to correct observation is a most difficult art acquired only after long experience and many errors. The difficulty lies largely in unsuspected bias. People forever see what they want to see or what they think they ought to see. That's one of our biggest problem as human. You see things based on what your mind has been tuned to. You have to untune that mind. You have to let loose of that mind and see things with an inquiring mind. Question things. Why is this thing like this? What if it is like this? Then how can we make it work? So as it is said here, correct observation comes from long experience. Now, speaking of this long experience, you don't get it if you have not been over time observing things with an open mind, an inquiring mind. And this is only possible if you have been observing without bias. Bias in the sense that you might just have this natural prejudice for people of a particular tribe, maybe because of what you were being told as a child. I think there's this very I think that's the daughter of Chinua Achebe. Yeah, I read one of her book talking about one story. Many of us move around with one story, in the sense that what you have been told or what you have heard about a particular tribe, a particular set, a particular group, you don't even want to see the other way around things. It's just that one story you are moving around. That's the bias. So for you to have a correct observation, you must get there's no way you get it from experience. And this experiment must have been how you have escaped from observing things based on bias. So we have that as that. Now it is extremely hard to rid oneself of such unconscious prejudice and to see just what is actually there. No more, no less. That has to do with observing. It's very important. So we have that as that. So after an observation has been made, the second step of scientific method is to define the problem. Defining the problem. Now, in this step, questions are asked about what you have observed. If our hypothetical student shows further curiosity, he will decide to find out why those seedlings have pale yellow leaves instead of green. You can just observe, and it feels like, okay, this is a waste of time. Let me just abandon this. And let's not forget, we said observation has to do with seeing things with an inquiring mind. Now, an inquiring mind will not just stop at observing. An inquiring mind will take a step forward. And that step forward is number 2, which is problem definition. Showing curiosity. Then it will decide to find out why those seedlings have pale yellow leaves instead of green. This is the definition of the problem. He will begin to ask himself questions like, why are the leaves pale yellow instead of green? This is kind of casual question that the scientific method deals with. Science is fundamentally about finding answers to questions. So after observing, then you have to begin to dissect, begin to break the questions into pieces. You understand? So that's that for that. So we have, significantly, not everyone sees that there are many that they may actually be connected with observation now. Now, for thousands of years, even curious people simply took it for granted, that any unsupported object that is thrown up in the air must fall to the ground. It took genius, the likes of Isaac Newton, to ask, how come? The nature of science. Asking question. Inquiring mind. And a few questions have ever contributed more to science as this. Good questioning, like good observing, is a high art. Good questioning, like good observing, is a what? High art. To be of value to science, a question must be relevant and it must be testable. To be of value to science, a question must be relevant and it must be testable. Experience helps in deciding if a question is relevant or not. To find answers to scientific questions, scientists use past experience, ideas, and observations. To find answers to scientific questions, scientists use past experience, ideas, and observation. So we have that. So we proceed to number 3, which is hypothesis formulation. Now, this is the third step in scientific method. Do you know that this involves the seemingly quiet, unscientific procedure of guessing? Synonymous to hypothesis is guessing. One guesses what the answer to the question might be. Scientists call this assumed answer hypothesis. A given question, as you might be aware, may have thousands of possible answers, but only one right answer. Thus, there are excellent chances that a random guess will be wrong. And the scientist will only know if his guess was correct after. Okay, Miss Justina, it's great to have you join us, although you came a bit late. Now, scientists will only know if his guess was correct after he must have completed the fourth step of scientific method, which is experimentation. Thus, nature of science. The main function of hypothesis is to predict new experiments or new observations. Now that you have observed, now that your curiosity has made you define the problem, now you need to begin to test. You need to begin to give predictions, assumptions, so you can have something to test. Now let's use the example we've been using, which is the hypothetical student. The hypothetical student now will try to state all the possible explanation to what he has observed. After he has observed that this maize grain is yellow pale as against grain, what could have been the problem? He begins to give, assumptions. They are called assumptions, possible guesses. So that's that for that. So we have okay, I think mouse. Yeah. So we can just move on to the next thing. Okay, now let's just quickly take this down. Obviously, much faster progress would be made if the number of hypotheses were few. So even when making hypotheses, you need to be careful of how many hypotheses you are making. Now, the amount of previous knowledge or experience a scientist has enables him to achieve this. This shows us the importance of knowledge for scientific progress and truly social character of knowledge. You have to be knowledgeable as a scientist. It makes your work easy. And how do you get knowledge? Is by reading, by making research, the like. So if you may recall in section 3.4 of unit 1, now we talked about hypothesizing that common sense, intuition, and lucky accident help science enormously. Just like this is just confirm what I've said. As a scientist, you have to be very knowledgeable. Intuition, lucky accidents, common sense help scientists enormously. Okay. Now, let's just quickly go through this. Now, the story has it that in one famous case, there's a German chemist called Kekule. Kekule went to bed one night after a fairly alcoholic party. In his sleep, he dreamt of 6 monkeys chasing one another in a circle. The tail of one held in the teeth of the other. Practically, our whole chemical industry is based on that dream, because it told the sleeping scientist that the structure of benzene was. Now, his dream actually was an insight. Scientists at the time had been trying to figure out the structure of Benz. Now, Kekule then conclude that Benz has 6 carbon atoms chasing one another in a circle. And that's exactly the present structure of Benz. And it is good to know that Benz is the fundamental parent substance for thousands of chemical products. I think the word is benzene. Benzene, I beg your pardon, not benz. Benzene. Yeah. So, now, science, it is the function of every experiment to test the validity of scientific guesses. So we have the fourth step, talking about experimentation now. So we have experimentation. Now you might be aware by now that answers without evidence are really unsupported opinions. Answers without evidence, they are unsupported opinions. Experimentation can provide the necessary evidence, and anyone who experiments after guessing at answers become truly scientific in his approach. So experimentation provides necessary evidence. So we have that as that. So let's just move on. So we have the fifth step, which is the conclusion. Now we shall again illustrate this step with our hypothetical above student. Now the test of the fourth hypothesis leads us to reject the hypothesis, while our test of second hypothesis leads us to accept the second one, which is the alternative hypothesis. Therefore, respective conclusions are: yellowing of the leaves was not due to the variety of maize germinating. Exclusion of light caused yellowing of the leaves. Now, scientific conclusions can be redefined, modified, and clarified when the situation arises. Some other conclusion may even be overthrown and discarded. For instance, young man who observed yellow pale leaves of maize seedling may want to find out if same results will be obtained when seedlings of other plants. He may also observe that in a large farm, some rare seedlings which lack green pigment completely may exist. This will lead him to modify his original conclusion. So we have number 6, which is the final step in scientific method, and it's called theory formulation. Now, what is theory? Would you be able to attempt an answer? If you cannot, let's talk about the definition. Scientific theory is an explanation about the cause or causes of a broad range of related phenomena. It differs from scientific hypothesis in its breadth of application. Now, a theory is usually proposed when an hypothesis when an hypothesis has been supported by really convincing evidence. This device must be obtainable in many different laboratories and many independent research. Before your processes and everything, experimentation and everything is put into good use or becomes relevant, it has to be tested. It has to go through a process of testing. Now, theories are open to test, revision, temptation, acceptance, or rejection. So that's that for theory. So we will move on. Now, how is science applied to reality? What what makes science important in reality. Now we have just gone through the process of scientific method. How do you think it can help in real life? Now let's suppose that you wake up one night with a skin rash. Skin rash now you observe. You want to know what caused this rash. Casual question. Your first type you first try to figure out how this situation is similar to other known situations. Perhaps a classmate of yours had a similar rash that was caused by an allergy to the grass at a close by a football field. You realize that your rash has appeared because all the football games that you have played on that field. Similarity, now analogy between your friend's allergy and your rash leads to the explanation of your hypothesis. That your rash is caused by an allergy to the grass too. So now, having known all these steps we've talked about, 6 different steps, we are seeing an illustration of a boy who wake up in the morning and suddenly find out that he has rashes. So begin to ask questions. You understand? Then went further to inquire how could this have happened after he has compared to his previous experience. Could it be from the football field? Could it be that somebody has the same rash and he made contact with the grass and I made contact with the grass at certain times? So all this prediction, hypothesis and everything, all this applies to reality. So we have that as that. Now, if we agree that all this seems like common sense, which it is, now the use of scientific method is not restricted to scientists. For example, in 1820 at New Jersey, USA, a colonel named Robert Johnson used scientific method to disprove the belief that tomatoes were poisonous. A colonel, let's take this down, a colonel named Robert Johnson used scientific method to disapprove the belief that tomatoes were poisonous. He bravely claimed the step of a city courthouse and ate a basket of tomatoes. Now this action greatly amazed the 2,000 town people who thought that tomatoes were poisonous. His bold experiment and his result proved the townspeople wrong. Now, a principle characterized of scientific thinking is that the sequence of observing, hypothesizing, experimenting, concluding, and interpreting is a circle, according to the characteristics of critical scientific thinking. The sequence in it is observing, hypothesizing, experimenting, concluding, and interpreting is a circle. Now, with new ideas produced at every step, to the curious scientific person, a conclusion or a theory is never the final answer. There is always something more to study, something new to learn. Can we be that person? So we have that as that. So now we are moving to how it works in science. So we have that Okay, so let's just quickly go through this. Now, scientific method works in a real life situation. Now, one example would be to illustrate how a real scientist made an important discovery by using the method. In the beverage 1970, it was reported that in certain parts of Great Britain, the Western Australia, there used to occur a nervous disease of sheep known as swayback. Let's take note of this. Where is this thing happening? Great Britain and Western Australia. There has to be an occurrence of which type of disease? Swayback. It's an observation. Now, the cause of this disease baffled investigators for years. Casual question. In Western Australia, a scientist known as H.W. Bennett, for certain reasons, suspected that the cause of the disease might lead to position, meaning positioning. As hypothesis formulation. Now, and the term my material just used there. Okay, I think we are good now. Okay. So now the term ammonium chloride, according to the illustration, is used as the antidote. The antidote. You understand? Is used as the antidote. So we have the first trial with this chemical gave promising results and enabled the ship to recover a little. But subsequent trial did not confirm the first results. See? A question then arose: why did the initial treatment with ammonium chloride give some relief to the ship? That's a casual question. Now, this suggests to Bennett that the cause of disease might be by the deficiency of some mineral which are present in small quantity in the first batch of ammonium chloride. Now, Bennett went ahead to find out the consistency of the ammonium chloride, which is the experiment. Now, he found that the copper was present in the ammonium chloride in small amounts as an impurity. So this is just trying to explain to us that is actually applicable to reality. Science is applicable to reality, and you can see the step-by-step process scientists are using in solving the arised problem. So we have creative and critical thinking. We live in a complex but rapidly changing society. In this society, we have to make simple or difficult decisions every single day of our lives. Such decision might be vital to both our own and other people's health, success and happiness. How well the decision turn out to be will depend in the part on the procedure thinking we use, the procedure inking we use. And the importance of scientific method of thinking is richly illustrated by the issue of science. And the importance of scientific method is richly illustrated by the issue of science. Now you will learn about until 17th century, science progressed quite slowly. Until 17th century. Now, in the last 3 centuries, procedures of thinking, the scientific method, which we have just discussed, evolved. Now, its use has been responsible to a large extent for impressive successful of modern science in discovering the secret of the universe. Now, many of us in our most serious problem can we lessen or even solve the application of this technique? Excuse me. So speaking about critical thinking, science plays a serious role. We will say something about experience. You need experience. It makes work easy for you as a scientist. But even though as a non-scientist, it is required for you to gather experience. And how do you guys explain? You have to learn new things, read books, discover new things, and you surely have experience in some sort of field. So we have that. So we have progress in solving most human problems as lagged for behind progress in science. Now, most human problems cannot, of course, be taken in the lab to be worked on, and some aspects of scientific method may not apply to this problem. So we have the procedures of science, which you have just learned, require two distinctly different types of thinking, which is creative and critical thinking. As a scientist, an individual, you have to be able to be creative. Imagination, the power of imagination should be perfect and critical. Scrutinize this thinking. Creative thinking may be defined as the formation of possible solution to a problem. Creative thinking may be defined as the formulation of possible solution to a problem. Now, effective thinking is both creative. I think I'll skip something. Okay, creative thinking on the other hand. Okay, okay, now so we've spoken about creative thinking. Now we have critical thinking on the other hand, is the testing and evaluation of these processed solutions. Technically, critical thinking now has to do with the testing and evaluation of these processed solutions. Effective thinking is both creative and critical thinking. Indeed, both kinds thinking are essential. Okay, we have that as that. Okay, we have the general process of applying creative and critical thinking to problem can be described as a circle of 6 phases. You have already studied. Okay, now we're talking about that. Sorry, 6 places, 6 in 6 stages of steps in science. So we have that as that. So now, by now, you should know that every phase of decision making is strongly affected by the fact that each one of us sees both the world and ourselves from our own personal point of view. And let's not forget, in science, you have to kill bias. This can interface with objectivity, which is important to effective thinking. How effective our thinking is depends partly on how objective we are in viewing ourselves in the world without bias. So now, keep in mind 2 essential things for objectivity. First, concentrate on the pursuit of truth in all your problems. No matter how unpleasant or threatening it may be, science has a system of punishing failure of objectivity. But in human setting, you must develop your own sense of discipline. The second element has to do with open to your feelings. Be open to your feelings. Exclude them when they are not relevant and include them when they are. Is this not practical enough? I apply this in basically in all our day-to-day life. Now, it should now be clear to us that perfection in thinking cannot be attained. Effectiveness is the important thing. Also, satisfactory solution to every problem is too much to expect. The person who expects to solve every problem and make the right decision every time is unrealistic. Now, effective thinking, like laying a musical instrument, requires practice. This is important both for understanding the techniques fully and for developing skills and applying them. So that's just that for that. So we have our conclusion. We'll be able to introduce ourselves. We'll be able to introduce to the scientific method of acquiring knowledge. Now we all know what scientific method of acquiring knowledge entails. Now how we have also learned how it can be applied to solve real life problems and scientific problems. Thank you very much. We have a summary, which is a observation, problem definition, by the steps in scientific method. We have the observation, we have the problem definition, we have the hypothesis formulation, we have experimentation, we have conclusion, and we have theory formulation. So thank you very much, guys, as we will join the curtain here tonight. I hope we are all and just before I close today's class, we run off for today's class, I just would like to talk about something which has to do with our forthcoming exam. I think I've been getting these questions a lot from a lot of persons. Your computer-based exam is going to go this way. CBT is called. You have to, as many of us who doesn't know our matric number, please, we need to know our matric number and our password. I think there is no issue with the matric number because your exam clearance, the pass you are going to use to enter into the exam hall, has your matric number. Now, the bone of contention is that you need to know your password of art. You have to have it at the back of your hand. I don't mean right at the back of your hand. I mean have it at the back of your hand, meaning that you can easily remember it. It is necessary. Secondly, as you log into your portal, your exam portal, your time starts counting. Okay, maybe before I say these two things, when you don't use paper, okay, now it's not necessary. And there are sometimes you enter into exam or you notice that your questions have not been uploaded. Just call the attention of the invigilator, they will help you sort that out. There's no need for you to panic. So when you log in, your time starts using immediately. So you want to be very focused. You don't want to be distracted as you go through the exams. So now about the exams, we have two types of questions. One question is that you are not required to use the keyboard, you are not required to type. They are called objective questions. They come with objectives, they come with options. But there are some other questions that they are called sub-objective. They don't come with options. You have to take your cursor into the provided box. There will be a box provided where you can type. And this is where I keep emphasizing. Get familiar with the material. Know how to spell the names, know how to spell the terms and the words. Because if you miss an alphabet when you are typing your answer, it will be a problem. And for questions that start with dash, for some objective questions that start with dash, if you are starting your first, if the answer you are putting is the first word that makes the paragraph or that makes the sentence, please let your first alphabet be capital letter. Then you can type the rest as small letter. So I think that is that. So as soon as you are done with your exam, I really recommend that you don't let the time count. You don't have to run out of time or count down on you before you submit. At least you have 5 minutes extra before you submit. You're done before 5 minutes the time is going to be over. Submit your, I think when you scroll down, you see submit all. When you submit all, to actually submit all again, you submit it again. Then it brings out your result for that particular course. If it's over 70, it will divide your total score by 70. So by 100, it's divided by, there's a way you do their division. But the very first score you are seeing is not your main course. It's not your main score. It's not your main grading. It's the next one that shows after they have done the division. Just scroll down, you see it. And please take note of that because you can tell in this course whether you're having an A or a B, considering the fact that you have gotten nothing less than 20 or 18 in your TMA. And if you write the course, you write an exam and you're having about 30. For it, if you have 20 in the course, like in the TMA, you're having like 20 again in the exam, that is a pass. But in the exam, you're having like 40 or you're having like 35. And your TMA, you only have like maybe 15, you have like 18 or even 20 or 30. and they go together. There's a tutorial on this my channel that I explain what each grading means. What 39, what 30, okay, I think what 39 to 45, what grade is it? Is it a D or A? Is it a D or a E? I've explained that. What 49 to, okay, what 49 to what 50, the range of scores under 50, 60, 70 and above. Whether it's a or a D or a C. I've done this tutorial. You can check the channel to have better understand. That's basically how it works. No stress, no issue. Where the thing is, where the work is, for you to study your material and get familiar with it. With that, you are good to go. Thank you very much, guys. And I wish you success in your studies. Bye bye.